This tab deals with binary math. We're going to start by converting from decimal to binary. Now, remember, you think individual digits, just like the odometer in your car has a digit to represent the ones position, so does binary. But whereas the next position is 10 times larger in your car, it represents tens, 10, 20, 30, 40, you only get 2 times larger. It's binary. And sure enough, you'll notice right above me, you'll see 2 to the first power. That is how it's always shown in most of the major textbooks. But I'm not going to worry about the powers. I'm just going to double everything. Instead of multiplying by 2, it's the same thing. So I get 2 times 2 is 4, or 2 doubled is 4. I can just add 2 plus 2 and get 4. About 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32. 64, 128, and even 256. Although if you're working with binary, you may see numbers that large. If you're working with subnet masks, you're never going to see a number that big. It's just not going to be a number you need. So the first number we're going to work with is decimal 48. So I've got to do something with decimal 48. I've got to find digits to represent all of that whole 48 value. There's not enough in 48 for me to use a 256 or a 128 or 64. But you'll notice there's 32s. How many 32s are in 48? A single one. Okay. So I'm going to put a 1 where that 32 is. And then say to myself, okay, how much of that 48 have I taken care of? 32 of it. It's okay to do long subtraction and math and addition like I did here. I do that on exams. You can do it in the real world too, just to be absolutely sure. Okay, continuing downward, we know that since there's even less left, there's still no way there's any 256, 128, 64s, or 32s left. Could be any 16s? Well, sure enough, there is. How many? There's exactly 1 16 left. Okay, so let's take that 16 off and look at that. We've accounted for all of the 48. So now I know there's going to be no 8s, no 4s, no 2s, no 1s. And look at that. I now have a representation in binary of the decimal 48. It is this number right here. Depending on, just like you have leading zeros in decimal, you might write 123 as 00123. It's still 123. You can have leading zeros in binary as well. When you're working with subnet masks or IP addresses, they'll be broken into 8 binary numbers. So what I have here is actually 9, as you'll see. So if we were working with that, I would take off this number and just represent it as 00110001. And that's the conversion there.